Okay, welcome back, everybody. We're going to have our last topic here with Brian Whipker talking about application methods, focusing on substrate drenches and bulb soaks. After this, we'll have about 15 minutes of question and answer with both Brian and Joyce. Before we go any farther, I do want to thank Fine Americas for their sponsorship of this e-GRO webinar called PGR University. It's a huge thing for them to be able to sponsor this and make this available free of charge to the growers out there listening. If you haven't downloaded any PDFs for this, feel free to go to the materials tab on your control panel and download the PDF so that you can follow along and use these for notes. Without any further announcements, I want to welcome back one more time Brian Whipker from NC State University, as he will talk about substrate drenches and bulb soaks. Brian, let me go ahead and mute you. There you go. You're ready to go.
Okay, I think I'm here. Just one correction is Joyce Latimer is after me for another 20-minute talk.
Sorry.
So she's coming back, and then it's going to be questions. So Joyce covered the concepts of foliar sprays and liner soaks. So the other primary application methods that we look at is drenches and bulb soaks, and that's what I'm going to talk about in this section of the presentation. So when you see the two options, it's substrate and bulb soaks. By far, substrate drenches are being used, and I want to cover that in more detail. I'm really only going to talk a little about bulb soaks because it's pretty specialized, and there are fewer people who are actually growing bulbs. So when we look at drenches, it's the application of a PGR solution to the substrate. That PGR solution binds to the substrate, and then usually it's released over time. And so we then have some absorption of that PGR by the roots, and so we get the growth control on that plant. So of the chemicals that we had, both the anti-GA types and the structural type, there's a number of them that are suitable. Those are the ones that have not been have a box over them, because dimenazide has no activity. GA, actually I have to admit I don't know if it does, but I didn't see the kind of ponder the significance of doing it, because you want the stems or the cells to elongate, so you probably need to be applying it to the stems. And then, as I said in the morning session, chlormethoxide chloride is suitable and registered for a drench, but probably not very cost effective. And so what are we left with? Acimidol, fluoroprimadol, Paclo, uniconazole, BA, the combination, e-GRO, and then Ethephon. And of those that are really, let's just say, the ones that are most commonly used or the most suitable for the effects are the ones in the red boxes. Top floor, the Paclos, the uniconazole, and Ethephon by far are the primary ones used by the industry, and they work very well in a lot of applications. So why use a drench? There's some advantages there. Because you're usually adding a drench with sufficient volume of water, and it goes over the root system, you have a very uniform response. Unlike maybe sometimes a spray application, if there's a shoot underneath the canopy, it does not get hit as well. You're not going to have that translocation and control, then that plant can become uneven. Also with the drench, because it is absorbed and then released, you usually have some more long-lasting control. And there's also the advantage that some of these low-dose drenches that can be made late in the season will control growth, even if you're using like 0.1 part per million, and then you don't affect flowering or bract development. So you can get the control you want without having the negative effects on flowering. So it works very well. But with that comes some disadvantages. The biggest one is, if it's not registered for the chemical to be going through chemigation, is the labor. The labor to apply it. It's much quicker to apply a foliar spray than a drench. And you can have some decreased efficacy if you're using a mix that's heavy in bark. typically we say you got to increase the rate by about 25%. And sometimes if you get too high of a rate, you prevent growth from occurring on that plant. So the keys here for drenches is to identify the proper volume that needs to go on to different pot sizes. You need to apply it when the substrate is not saturated. It's a little on the dry side. It needs an irrigation so it can be absorbed and retained in that pot and not drain out the bottom. But it can't be too dry, because otherwise it might channel along the outside and out to the bottom. And like I already said, if you have a heavy amount of bark, sometimes it can tie it up, and so people sometimes increase the rate about 25%. But if you're doing sub-irrigation, you can use a lower rate, because a sub-irrigation, what's the wicking pattern? The wicking pattern is things move to the top, so you're not having a leach through of some of those chemicals, so you can lower the rate and get very good results. So the guidelines are out there. It's on all the labels for the drenches that you need to match up the number of fluid ounces with the pot size, and typically that goes up, or it does go up. With the bigger the pot, the more solution you add. Again, to get that uniform coverage and distribution inside that pot. That's why we're using that higher rate. So when you look at volume for these soil active PGRs, the volume does depend on this method, and it's critical that you have the right amount of volume to get that uniformity and response. So volume can also be used in some cases as an application tool, in that if you want to add a little more volume, what are you doing? You're adding more chemical, so you'll get more control. Whereas on some cultivars that might be less are very reactive, and you want to use a lower dose, you can lower some of the volume. So when you're doing the application, you can customize it with only having to make one solution. You customize the rate, the ultimate dose you give that plant by changing the amount of volume of water that you're applying. So here's some results that we had with top floor a few years ago. You see the response of increasing rate of foliar sprays from 0 to 50 on the top photo, and the bottom photos the drench application. So you can see, you get in many cases a little more control with a drench than you do with the foliar spray. Here's some of Joyce's work looking at sprays, the untreated control at the left, a spray of 160 parts per million of piccolo, and then drench rates increasing. So, it's a little extreme on some of the rates, especially on the far right side. This is only 3 weeks after treatment, but you can see the effects and going on, so drenches have some activities. Here's some work, or here's actually the plants a little later. 6 weeks, so you can see that like the 8 part per million drench held back that plant. It's nice and compact, whereas the other rates were a little on the excessive side. Showed this slide earlier. Here's drench summaries of for this one cultivar, summertime sunset. Top floor drenches applied 1 part per million before vernalization began, and then I should step back, before chilling period began, because vernalization implies you need the cold temperatures to induce flowering. That's not the case. You kind of sink it is what you're doing. So when cold temperatures began, 1 part per million drench was added, and then when we increased the temps after about a month, I believe, we added another one. So top floor worked great. Sumagic works for a drench, more responsive effect that occurred here with the pink charm, that you can see the effects going on. So very, very much a suitable application method. Top floor drenches here, looking at stargazer lilies, looking at probably 0.25 milligrams AI as being a good rate to hold the plants down and get good coloration on those. I showed this earlier in the morning, concise drenches, just to hold down that stretch in post-harvest with concise, using the rates in the middle range that's there. Top floor, we did the work looking at caladiums. 1 to 2 milligrams AI is good. Very similar rates for a Paclo product, but interesting enough, a caladium is one of the few plants where a uniconazole does not really work. It's probably the only one I know of that's out there. So anyway, you need to use a Paclo or a top floor for caladiums if you want to control some of that stretch going on. And here we are with tuberous dahlias. You can see the rate response as you control growth between 1 and 4 milligrams AI. So I want to shift gear just slightly and look at Collate drenches. And so really it's Ethephon that we're looking at. So there are 2 Ethephon products. There's Collate and there's Florel. For drenches, we're looking at the rates between 125 and 500 part per million. And so you need to apply it with a similar amount of volume of water as you would with any other drench, and don't have the plant stressed. Now, the label is not quite there yet. The label has been applied so the submission process is starting by FINE that they are going to get they're working to get a substrate label for that product, because right now it's not listed. Only sprays are on the label for what's on the marketplace right now. So we did some earlier work with Florel, but it's the same with Collate. If you get too high of a rate, you might get some lower leaf yellowing, like on the left, and you can have some upper leaf yellowing if it's a little too high. That was with 500 part per million. We only really tried one rate initially, and that's a little much on the control side for this plant. Because we've found that for the most part, 500 part per million, what you use for a spray, you need to half that down. I would highly recommend, if you're going to do a trial, you start with 125. You maybe try 250. But you don't need to go up to 500 parts per million. And Vista bubblegum's a very vigorous plant, so that would be the option for you to consider if you're going to do some trials. And here's some trials we did with geranium. And you can see the growth between 125 and 250 part per million. Gave excellent full plants, good results. Substrate drenches on coleus, same thing. 125, 250 would be where I look at. So once it's labeled, you're going to have to do some tests to look at optimal rates. There is a lot more variation that goes on as far as the response is concerned based on species and cultivar. Apply a similar amount of water, i.e. like on a 6-inch pot, it's very common on a drench to add 4 fluid ounces. You need to follow that. No stress, and the label hopefully will be out fairly soon, so you can use this with your operation. Now, I want to briefly talk about it's kind of my pet peeve, let's call it, on doses. And we, as university people, and I know some of the other industry recommendations out there, we're not quite doing our job on fully giving the rest of the story on our recommendations. And so what I mean by that is that when you look at a drench dose, it's based on measuring out a known amount of chemical, adding that to a known volume of water, and applying a known volume to each pot. So the first 2 factors will make the concentration of that solution. The volume, so concentration times the volume, then will equal the dose. So that is what we're giving per plant. So when we do milligrams of AI, we in fact do that. But with a part per million recommendation, I want to say we're being lazy because we forget the volume part. How many times you look at a recommendation, they say, apply this many part per million of a drench. It doesn't matter if it's Ethephon, paclobutrazol, whatever. We need to say how many fluid ounces so we know what we're giving to that plant. Because again, the number of fluid ounces per pot varies with the pot size, as you see in this slide here. And so when you get a recommendation based on active ingredient per pot, it does take into account for that volume difference. And typically, or what it does happen is the dose stays the same across the pot sizes, only the amount of water that's used increases. So you're just diluting it, but the number of milligrams that's in that dose, if it's going to be 2, it might be 2 milligrams in 4 ounces of water, or 2 milligrams in 8-ounce drench. You're still giving 2. And the part per million, again, we're not saying how many fluid ounces, and that's important, so you know that you're not overdosing the plant. And here's an example. Parts per million is milligrams per liter. So if you mix a solution at 50 parts per million and you made it in a liter, that's 100 mils, then that 100 mils, that liter, has 50 milligrams of that chemical. So what happens if you change the number of mils you add to a pot for that plant? If you add 10 mils, it's going to give you a 0.5 milligram dose, and the math there you can follow. If you add 100 mils to that plant instead, what is it? It's 10 times higher, so it's 5 milligrams. And if you added that whole liter to the pot, you're going to give it 50 milligrams. So the volume that you're adding makes a big difference on what total dose you're going to give that plant. And so we gotta be consistent so you don't mess up, because we didn't give those rate recommendations. So in parts per million, the bottom line is, if someone says rate, you say how many ounces are you adding then. The milligrams active ingredient already takes care of that. So either way you do it, it's okay, but you got to know what that ending dose is for that plant. So the final area that I need to cover is bulb soaks. It's not as common of an option because a lot of people aren't producing bulbs, so it's probably not quite as relevant. I just looked at the number of people that are on the screen. I'll see are attending, see if anyone drops off now that I'm going into bulbs. But on pre-plant soaks, it is a pretty darn cost-effective treatment. Typically what you do is you mix the solution in a bucket. You'd like the water to be room temperature. If it's too cold, you're not going to have quite as much uptake. So you want room temperature water, not ice cold 35-degree water out of the well if you're up in the Midwest. So overnight, bring the water in overnight in the greenhouse. It's going to warm up. And typically you soak the bulbs in that solution for 2 to 5 or up to 10 minutes. It doesn't really matter as much. And then let the bulbs drain, and then you can plant them up. Typically, in our experiments, we'll soak them for the time, drain them for an hour, then pot them up. But to get around REIs, you can do that the morning or the day before, and typically most REIs are only 24 hours. Then you can pot them up and not be so concerned. So simple procedure to follow for that to happen. So which chemicals are the ones that are possible? It's really the ones that are still viewable. Acimidol is a possibility, but probably after you look at the activity of fluoropyrimidol, paclo, and uniconazole, those would make probably a better sense for you to look at, and they're more active and they work very well. So here's some work we did. Jared Barnes, a former grad student now down in Texas, he did this on some tiger lilies. And you can see the pre-plant soak that you start getting control. We still had, as Joyce said, we still had a linear response there, although we were getting close. But if you want to sell that plant somewhere between a 5 and 10 part per million, it's going to be a little easier to get in a car than the higher rate. So that's a rate that worked pretty well. Brian Krug's work with his masters looked at different rates. We thought we'd have to go higher, and that's why the 400's there, but it knocked them pretty hard. But roughly about 25 parts per million. Top floor worked very well on some of the hyacinths. 25 parts per million on some of the tulip varieties that he looked at also worked well. 25, 30 parts per million also worked for tete-a-tete. And again, we're looking at the stretch after they go into the post-harvest. So we're avoiding that excessive stretch, and that worked very well for a rate. Now, we did a lot of work trying to develop pre-plant bulb soaks with top floor on Easter lilies. We started the trials using the original Stargazer rates, and we said, oh, this should work, and it nailed them. That was the lowest rate, and it nailed them. So then we came back through, and we did another study, and we got a great response. And we said, man, this is dirt cheap. This works well, and it does. The only challenge is it does work really well. Here's a close-up that, 0, 1.25, 2.5. And anyone that grows lilies knows there's a seasonal variation on those plants as far as how much they're growing and everything else that's going on. So it really came down to it that 1 year 1.25 was good. The next year it might have been 2.5, but that would have overdosed it the year before. And then we had another year where 1 part per million worked better. So we never got down to a rate that was consistent enough to give an end product that was suitable. So the bottom line is, even though I love these slides and I love the results, we didn't have consistent results that we would then end up saying, you as a grower, try this. Because again, it's a pre-plant soak. You already put all your eggs in a basket before you started, and we had too much variation that would not enable you to end up doing that. So on the key points on pre-plant soaks, when you look at activity, probably the most active chemical that's out there is going to be top floor. Uniconazole is next, and in some cases it has equal activity as top floor, and then paclobutrazole. There might be a few species where it doesn't work quite as well, but it still can work, but probably cost effectiveness wise, the other two part of that are going to be better. We found that top floor was very effective. If you're going to start some trials, I would suggest starting with that. And if you know any rates that's been published that are like Sumagic soak rates, I'd start with that rate for your trials. And it's, because of the active ingredient and how active it is, it does have some good economics there. It's probably your lowest cost option of using fluoropyrimidol. So with that, I'm at the 20 minutes, and I'll open it up for some questions.
Okay, Brian. Honestly, I'm a little offended that you thought that the attendance would go down when you start talking about the research that I poured my heart and soul into over 2 years.
Oh yeah. All right. Did you call your family so you had more people sign up during this part of the session? Brian Krug did amazing work during his master's degree on bulb. It's probably part of his life that he's glad he moved north that he could forget.
All right. So the first question is talks about any question about tank mixing Daconil with Weatherstick with a PGR, particularly concise, that the residue from the Daconil holding the PGR on the leaf too long?
I don't know that answer.
Dumper.
Anytime you start getting into tank mixes, I think you're going to have to trial it and just see, because there's just too many combinations that are out there. Most of the PGRs that out there, they have acidifiers, they have agents that kind of keep things in solution and together. I mean, the first thing you'd, of course, maybe do the jar test to see if there is any reaction and it flows to the bottom of the jar, but that's really not what the question was. It's once it got sprayed, is there a reaction? There's a spreader sticker in most of these PGRs, so hopefully that will keep things separated, but I don't know the answer.
Okay. A question about any research done on plants growing from tubers or fleshy roots, like ginger. I know you did talk about caladium a little bit. Any other plants that fall into that category?
We did some dahlias, and I think Brian had already started the job up in New Hampshire. So dahlias would be, and this was a tuberous dahlia. It didn't work it worked, but it didn't give you what you wanted. I believe the plants were bigger diameter and they were delayed forever. So what I would suggest is that if you're going to do some trialing, fluoropyrimidol is going to be a pretty good product. So if sometimes on the bulb work people have done, there's concern about dryness of the bulbs. You might rehydrate them the day before in water just to make sure they're even, then do the bulb soak the next day, and that will help on some of the uptake that goes on. The other thing, I'm thinking down the line of like a calla lily, and I think we did calla lilies that, Erwinia is a big problem. If you got any major disease issues, bacterial in particular, I wouldn't do a pre-plant soak. I would consider a drench, and you ought to get pretty good control with some of the drenches if you're going to start. That's probably going to be a safer rate or way to go. So I don't know that answer other than dahlias, and we were not happy with those results. We would not recommend them.
What about with calla lily?
Because of Erwinia, it's Erwinia. I wouldn't do it.
Okay.
It's too big of a risk of spreading it. Erwinia, it can hang out and you can keep it at bay in the plants, but here you are sticking hundreds, thousands of calla lilies in the same solution. That is bad production practices. I would do the drenches, and the drench rates are on the top floor label, and those rates reflect what we did at North Carolina with those plants. Off the top of my head, I can't tell you the rates because it was 8 years ago, but it's on the label rate for top floor, and I would start with the drench rate. Okay.
In terms of soaking bulbs, a grower is asking about the length of soaking. Is there a point at which time the soak becomes ineffective, or maybe that was the question, but I'm also wondering about if you can overdose a bulb by soaking it too long.
Well, I'm surprised, Brian, you're not answering this question. You did the work.
Well, I don't want to steal your show.
Brian, you can correct me. I believe Brian went all the way up to 60 minutes. He had different increments, and really after the only wobble was not doing it quite long enough at the beginning, like 1 minute. But after you got longer than 5 minutes, it was consistent. You concur with that, Krug?
Yes, and we tested up to 1 hour and saw no difference between 5 minutes to 1 hour.
The only difference that Bill Miller saw, again, was especially lilies that have the scale bulbs that could be subjected to more drying, that he found 1 year to the next, that if one lot was drier than another, the dry ones typically took up more chemical and you could have more of an effect than if they were wetter. And that's where that hydration comment comes in. And but typically you don't save any on chemical. You probably have to bump the rate up about 25%, if I remember correctly, because you've diluted it a little. But you don't get a lot of absorption of that PGR into it. You have a lot of that material left at the end.
Okay, we do have more questions, but folks, if you would maybe type those in again. If I don't pull them up later on, we need to move on to the next session. But we do have about 15 minutes that we can field questions to both Brian and Joyce after our last session here. So hold on to those questions. Don't let me forget about them. I'll try to return to them. If I don't, please go ahead and type those back in. But to stay on schedule, I want to switch back over to Joyce. So Brian, thank you for your time here and giving us your input. At this time, Joyce, I'm going to